orientation. So just as a reminder, we'll be working in the week 2 module in our Canvas shell. So we'll be working on the experiment 2, which is called conversion factors and problem solving. So if you click this page, it'll bring you to the page for today's laboratory. So in this lab, this is lab 2 in your lab manual. So if you go to vital source, this will be lab 2 in your lab manual. I'm pulling it up in vital source, but you'll pull it up in your lab manual, and it's called conversion factors and problem solving. That's the title of the lab. So in this lab, you'll be able to round off a calculated answer to the correct number of significant figures or decimal places. You'll be able to determine the area of a rectangle and the volume of a solid via direct measurement. You'll be creating equalities and relationships between units of measurement in the English and metric system. And you'll be using conversion factors and calculations for length, volume, and mass. So for required reading, you're going to need to read the introduction and procedure page of experiment 2 in your lab manual. And you're going to be recording your data and submitting your question responses on the lab manual data pages. Some recommended reading, I would recommend you look over the chapter 1 notes and the chapter 1 workbook. So I have some information on rounding off. This is fully a review from the chapter 1 notes. Just to go through it with you for the key points. So when you're rounding off, you indicate the last significant digit, you examine the digit after the last significant digit, and you round down if the digit is 4 or less, you round up if the digit is 5 or greater. I have 2 examples that are taken from the notes. For part B, significant figures and calculations, again, as a review from our lecture that we just had this morning, for multiplication and division, you retain the least number of sig figs. You may have to round. When adding or subtracting, you retain the least number of decimal places. Now, one critical prompt that you're going to be asked to do in this laboratory is to write an equality from your conversion factors. So whenever you have a conversion factor, you can write out the conversion factor as a ratio of 2 equal quantities. So for example, if we have a centimeter is equal to 10 to the negative second meter, we can write out this equality as a ratio where we have 10 to the negative second meter per centimeter. Now, again, make sure that your units cancel, and if units are on opposite sides of the dividing line, those units will cancel. Now, the metric system, as we discussed in lecture, is based on powers of 10, and you're going to be performing a series of metric to metric conversions in this class and in this lab. I provided you a list of each of the metric symbols and their prefixes for your reference. Now, I've also provided you some English to metric conversions. You may want to reference these English to metric conversions when you're performing today's lab. Now, to show you an example of how we can apply English to metric conversions, if we wanted to convert inches to centimeters, we know from our table, if we look, we know that there are 2.54 centimeters in an inch. So then, to go from inches to centimeters, we write out the equality of 2.54 centimeter per inch times 2 inches. All of these examples are taken directly and I have worked examples recorded from our chapter 1 notes. Finally, for problem solving using conversion factors, I have a guide on how to perform unit conversions that require multi-step conversions. So for example, if we wanted to figure out the number of milligrams in 3.46 times 10 to the first kilograms. We'd indicate our starting units and we'd indicate our final units. You always want to go through the base units, such as grams. Once you have created and referenced your equalities from your metric conversion table, you'll write each equality as a conversion factor, which is a ratio of two equal quantities. Then you multiply by your conversion factors, and you always keep the power of 10 with your base unit. This worked example was done in the chapter 1 notes. I've just rewritten it here with the full solution, just so that way you see how I would like you to format your responses in your lab report. All of your values are clearly written out with the proper units, and each step of the calculations is clearly indicated. So with the review out of the way, and there's additional review in the Lab 2 introduction, there are sample examples as well in the lab that I would recommend that you reference throughout this laboratory. We're going to be working on the experimental procedure. So for part A, rounding off, for part A, for rounding off, you're going to read part A in your lab manual, and you're going to read the part A data table. So for part A, they give you a table. So does everyone see this data table for part A? Does everyone see that data table for part A?
Yes, Professor.
Yes.
The rounding off the 8 and 800, I don't know how to answer that one.
So essentially what's going on in this table, just to go to the instructions, they will provide you, they essentially provide you a student response. So this is what a student has submitted for their answer. Your job is to determine whether the student has rounded this provided number. So whether they rounded 8 correctly, and then if it's correct, you don't do anything. But if it's incorrect, you write the correct rounded number in spot number 2. Does that make sense? So in this case, if you start with a number 8, if they're rounding 8, since 8 only has one significant figure, the correct number would just be 8. So you're essentially reading the student's work, determining whether or not this student response is correct, and then if it's incorrect, you write the correct response in space 2. Does that answer your question?
Professor, 8, if you round it, then that's supposed to be 10?
8, so in this case, they're trying to round 8 to 3 sig figs, but 8 itself only has one significant digit, so you can't add significant digits to that number. So if you're keeping 8 and retaining one significant digit, it would just be 8.
Okay, thank you.
In part B, significant figures and calculations, it's split into 4 parts: multiplication, addition and subtraction, and area. For part B1, multiplication and division, allow me to show you that section. So in part B1, they've asked you and they provided you 3 different calculations that you have to perform following sig fig rules. That's all you have to do, just like the problems that we covered in lecture. Does that make sense to everyone? Does that make sense to everyone? Okay, perfect. For part B2, you're just going to solve the addition and subtraction problems. So you have 4 addition and subtraction problems. You should submit 4 answers. For part B3, you're going to use a ruler and you're going to measure the length and width of the rectangle. So this is the rectangle. It's exactly the same as your report sheet rectangle. You're then going to calculate the area of the rectangle by taking the length times the width. You're going to post your measurements in the class discussion forum. This is how you're going to share your measured values. Then you're going to obtain a second set of measurements from another student and record those measurements. And you're going to calculate the area using the measurements from the other student. So here is the table that you'll be filling out in your report sheet, and you're going to answer the questions as well in your report sheet. Does that make sense? Does this make sense to everyone?
What was the second rectangle? I just see one rectangle in my lab menu.
So the second is another student's measurements. So I've given you the same rectangle with a ruler overlay for you to take the length and width measurements, and you're going to write down those values, and then you're going to share them with another student using the forums, and you're also going to write down another student's values, and you're going to compare them. Does that make sense?
Yes, thank you.
Perfect. So for part B4, we're looking at the volume of a solid. You're going to record the shape of the object, and you're going to use a metric ruler to determine the dimensions of the object in centimeters, and then you're going to calculate the volume in centimeters cubed. So I provided you the length, width, and height of the cube as image links. And that's where you'll take your length, width, and height measurements from. Does that make sense to everyone? Perfect. So for part C, first things first, you're going to deal with metric to metric conversion factors for volume. So I've given you a picture of a 1 liter graduated cylinder, and you're going to write an equality that states the number of milliliters in 1 liter. And then you're going to take that equality and you're going to write 2 conversion factors, 2 ratios relating milliliters and liters. Does that part make sense? Any questions so far on this overview for today's lab? What you're submitting, so each of these report sheet pages, you're filling in your responses in each of these sections. You're submitting all of your filled in report sheets as well as answers to all of the questions. And these report sheets, yes, are in your lab manual. So you'd be submitting either a photo, a set of photos, or a PDF that is legible that contains all of your report sheets filled in. Does that make sense? Perfect. So an example of an equality. So for example, suppose this will be a tangentially related example, but suppose a cubic centimeter, if we know our equality is a cubic centimeter is equal to a milliliter, the 2 conversions that we can write is that we have 1 milliliter per cubic centimeter, and we also know that we have 1 cubic centimeter per 1 milliliter. This would be an example of our 2 conversion factors for this equality. Does that answer your question in the chat that I saw? Does that make it clear what I'm expecting for this? Perfect. I'm going to clear these annotations because when you annotate using Canvas, it stays on the page. So I'm just going to clear this drawing. But if you have any other questions, don't be shy to ask and I'll be happy to clarify. I'm just going through each of these steps and making sure that they're clear, and you'll have the whole lab period to work through this lab, and I'll be available to answer questions as well. So there's one change that I'm making. So for part C2, you're going to follow this alternative procedure. So rather than measuring the volume in quarts, what you're going to do, what I've asked you to do, is to calculate the number of milliliters in a quart and write 2 conversion factors for that equality. So that's all I'm having you do for part C. So for part C, you're going to write the number of milliliters in a quart, and you're going to write the conversion factor. The true equality you get from your notes. Does this make sense to everyone so far? I just want to make sure everyone understands what we're doing for the lab today. I'm confident that everyone's going to do well in this lab because we've actually done a lot of these measurements and a lot of these conversions already in our notes. So for part C, we're looking at metric to US system conversions for length. So what you're going to do is I've given you the lab manual and 2 rulers, and you're going to measure the length of the page in inches and centimeters. Don't worry about the pre-lab. The pre-lab is going to be due with the report. The pre-lab is going to be due with the report. So you'll submit everything together as one document. So don't worry about that. So I'd like you from this lab manual page to record the length of the page in inches and in centimeters. Note the ruler that you're using is a centimeter ruler, just like always. Then what I want you to do is to divide the number of centimeters you measure by the number of inches to give a relationship from centimeters to inch. Then you're going to write an equality that states the number of centimeters in an inch, and you're going to write 2 conversion factors. So you're going to measure the length in centimeters, which is the top, and the length in inches, which is on the bottom. Make sure to follow sig fig rules. Does that make sense to everyone?
So this is for the C4 part in the lab manual?
C3. This is the length of the page in inches, the length of the page in centimeters, and then your ratio, and then your conversion factor. Does that make sense?
And there's a picture in the Canvas because I'm looking at my lab manual right now.
There's a picture in Canvas.
In the Canvas, okay.
Mm-hmm. And I even have the ruler set up, and this is a digital ruler that matches the ruler that you'd use in person. Does that make sense?
Yes, I have to go because I can't be in the 2 page at the same time. Look at you. I don't know how to do that. And then go to the manual at the same time on the Canvas.
It's okay. It's embedded into Canvas. For part C4, you're going to do metric to US system conversion factors for mass. One thing that I noticed, there was a typo in the lab manual. So the procedure that I have written here corrects the typo in the lab manual. So in terms of what you're doing for the part C4 section, you're going to write the name of the product, you're going to read the label, and you're going to record the mass in grams and the weight in ounces or pounds. If the weight is given in ounces, as in this case, you'll convert it to pounds, and then you're going to divide the mass in grams by the weight in pounds. Finally, you're going to write an equality that states the number of grams in 1 pound, and you're going to write 2 conversion factors. So here's a picture of a commercial brand of cereal, and it has the weight in grams and the weight in ounces that you're going to need to convert to pounds. Does that make sense? Is everyone comfortable with that idea? Just as a side note for students asking about the due dates, the assignments due this week are found in the Unit 1 overview, and the assignments are number 1, the lab number 1 report, number 2, the unit number 1 homework, and number 3, the unit number 1 quiz. This lab report will not be due until next Sunday. In general, once an assignment is assigned, it will be due the following Sunday. And I've scheduled the due dates in Canvas as the due dates approach. For part D, we're going to be using conversion factors involving metric height, and I provided you a sample height in inches. What you're going to do is you're going to calculate the height in centimeters, and then you're going to calculate the height in meters, showing your setup for each step. Once you've filled in that table, you're then going to answer questions 1 through 4. And that's all you're doing for today's lab. Does that make sense to everyone? So for the lab, you're going to complete all of the data sheets as well as the pre-lab questions.
So these are all due today or following Sunday?
It's due the following Sunday.
Okay, so today we start working on it, right?
Yeah, exactly.
Got it. Thank you. Okay.
And you can, and just as a reference, all of the due dates in Canvas that I will be collecting assignments for. So if you go to the home page and you view it from a student view, it will show on your to-do list, there are different announcements. And if you go to if you actually check your week 1 and week 2 overview, you can check the due dates of different assignments. So the Unit 1 report, it has it due this Sunday. The homework and the quiz are also set up in Canvas. And I can go through and make sure that it's showing up in the calendar page. So that's the complete overview for today's lab. It's found in the week 2 module, experiment 2. And you're going to be filling in your data on your report sheets, and you're going to be turning in a PDF or photos of your completed report sheets. Does that make sense to everyone? Is everyone able to find in their lab manual this lab? Lab 2, conversion factors and problem solving. Is everyone able to find this lab? Perfect. So what I'm going to do is I'm going to stop the recording.